All right, let's look at integrating sine square and cos x square. All right, sine square x and cos square x. All right, it says, example 49 says, find the integral of sine square x with respect to x. Now to the right, we have, I'm showing you an identity, something that you should remember from when we did trigonometry, that cos 2 theta, sorry, cos 2x is equal to cos square x minus sine square x. It's equal to 2 cos square x minus 1. It's also equal to 1 minus 2 sine squared x. So here I'm going to write that 1 minus 2 sine squared x is equal to cos 2x. So it means therefore that 1 minus cos 2x is equal to 2 sine squared x, which also means that if I divide both sides by 2, I'm going to get sine squared x is equal to a half minus a half cos 2x. Alright, so therefore the integral of sine squared x is the same as saying the integral of a half minus a half cos 2x, and I'm integrating this with respect to x. Alright, now if I integrate a half with respect to x, I'm going to get 1/2 x minus a half. Now if I differentiate sine, I get cos, therefore if I integrate cos, I'm going to get sine 2x. Then I have to divide by the differential of the inside function. The inside function is 2x. If I differentiate 2x, I'm going to get 2, so I'm going to divide by 2, which is the same as saying multiplying by a half. So therefore, the integral of sine squared x would be equal to a half x minus 1/4 sine 2x plus c. Alright. Alright, let's have a look at the integral of cos squared x. Now 2 cos squared x minus 1 is equal to cos 2x. That's according to the identity on the right, something that we did already. Therefore, 2 cos squared x would be equal to 1 plus cos 2x. If I divide both sides by 2, I'm going to have cos squared x is equal to a half plus a half cos 2x. So the integral of cos squared x would be equal to the integral of a half plus a half cos 2x. And I'm integrating this with respect to x. Alright. If you integrate a constant like a half with respect to x, you're going to end up with a half x. If I differentiate sine, I get cos. Therefore, if I integrate cos, I'm going to get sine. So it's plus 1/2 sine 2x. Then I have to divide by the differential of the inside function, which is divided by 2, which is the same as saying multiplying by 1/2 plus c. So the integral of cos squared x with respect to x would be equal to 1/2 x plus 1/4 sine 2x plus c. Alright, let's have a look at the integral of sine cube x. Alright, this would be the same as saying the integral of sine x multiplied by sine squared x dx. Alright, now sine squared x is the same as saying 1 minus cos squared x. So this would be the integral of sine x multiplied by 1 minus cos squared x. So this would be the integral of sine x, applying distributive law. Whatever is inside the bracket is multiplied by what is immediately outside the bracket. And this is sine x cos squared x, integrating with respect to x. Alright. Now, if I differentiate cos, I get minus sine. If I integrate sine, I'm going to get minus cos. So this is minus cosine. Alright, let's just separate this. This is the same as saying the integral of sine x dx minus the integral of sine x cosine squared x dx. If I differentiate cosine, I get minus sine. So if I integrate sine, I get minus cos. So this is minus cosine x. Now, if you look to the right now, you're going to see that sine x is the differential, or minus sine x. Alright. I'll do something here. This is plus, and then minus sine x cos squared x dx. This is equal to minus cosine x. Now, minus sine is the differential of cos x. Alright. So if you have an integral in this form where what you have is a product of a function and the first derivative of the function, then it becomes literally a power integration. So plus, I'm going to increase the power of cosine. The cosine cube x, increase the power by 1, and divide by the new power, which is 3. Now we also have to divide by the differential of the inside function. If we differentiate cos, you'll get minus sine x, so the minus sine x will cancel. And this is plus c. Alright. So, example 52. We're going to look at the integral. The integral of cos cube x is the same as saying the integral of cos x into 1 minus sine. Sorry, jumping the gun. You might not see it, so I'm going a little bit slow. So times cos squared x with respect to x. This is equal to the integral of cos x into 1 minus sine squared x dx. This would be equal to the integral of cos x minus cos x sine squared x dx. This would be the integral of cos x with respect to x minus the integral of cos x sine squared x with respect to x. If I differentiate sine, I'm going to get cos. Therefore, if I integrate cos, I'm going to get back sine. Because integration is the reverse or opposite of differentiation. Here, cosine x is the differential of sine x. Therefore, what this is, I'm integrating a product. It's in a form where I'm integrating a product of a function and its first derivative. All right, and if you're going to do that, it becomes a power integration. So I'm going to increase the power of the sine squared x by 1. So I'm going to get sine cube x divide. I'm going to divide by the new power. And I also need to divide by the differential of the inside function. The inside function is sine x. If I differentiate sine x, I'm going to get cos x, and the cos x are going to cancel. Plus c. All right. Now the integral of tan squared x. Here's an identity that all right. Let's start from scratch. Cos squared plus sine squared is equal to 1. Everybody knows that. Divide both sides by cos squared. Divide the entire equation by cos squared. I'm going to end up with 1 plus tan squared x is equal to sec squared x. So tan squared x would be equal to sec squared x minus 1. So the integral of tan squared x is the same as saying the integral of sec squared x minus 1, and I'm integrating this with respect to x. Now, if I differentiate tan, I'm going to get sec squared. So if I integrate sec squared, I'm going to get back tan. So this is tan x minus, if I integrate 1, I'm going to get x plus c, which is the constant of integration. All right. And lastly, I'm going to determine the integral of tan cube x. Now, the integral of tan cube x is the same as saying the integral of tan x times tan squared x dx. Tan squared, already shown, is equal to sec squared minus 1. So this becomes the integral of tan x into sec squared x minus 1. All right. And so this becomes the integral of tan x sec squared x minus tan x. And I'm integrating this with respect to x. All right. And all I simply did a while ago was to apply distributive law. All right. So now this becomes, let's separate it, the integral of tan x sec squared x minus the integral of tan x. So I'm integrating this with respect to x minus the integral of tan x with respect to x. All right, sec square is the differentiation of, if I differentiate tan, I'm going to get sec square. Therefore, this becomes, I'm integrating a product of a function and its first derivative. It becomes a power integration. So I'm going to increase the power of tan by 1. So this becomes tan squared x. I'm going to divide by the new power, which is 2. I should also divide by the differential of the inside function, which is tan x. If I differentiate tan x, I'm going to get sec square x. So the sec square x are going to cancel. Now the integral of tan x, I think, if I'm not mistaken, is this is minus ln, and I think it's sec x plus c.